about composite function might be a little bit different than like the method books given, or a little bit different from like maybe your tutor. So I'm looking like a graph. So hx equals to g of fx. Okay, we put function fx into the function gx. Okay, the new function h is said to be the composite of g with f. Okay, we can also write in this way. So g is in the front, open circle, and f, which means I put function f into the function g. Read as the composite of f followed by g. And the rule is given by hx equals to g of fx. So let's do a really simple example. Let's not look at the example below here. I'll show you this example, but let's look at a simple example first. Let's say fx equals to x squared. Okay, and then gx equals to x plus 1. But it's not enough. Like if it's just like a simple function, that's really easy to do. But if I have I restrict the domain for it. Okay, I restrict the domain for it. Let's restrict this domain. This domain can be r plus. Okay, I want all the positives. I want all the positives. For the second one, the gx one, my x only belongs to negative infinity to 4. Inclusive. Okay, now I will talk about new function hx. For this hx, I want to put the function f into the function g. Let's have a think what this question means. Okay, what this question means. Means I want to put a value. Let's put a value in first. Let's put the 1. Let's put 1 in. Okay, h1. What is h1? h1 is g of f1. So you, instead of x, you write 1. So on the left hand side and on the right hand side. So f1. Now let's evaluate f1. So this is like we calculate f1 first, and then we get the answer. Then we put the answer into the function g. So what is f1? f1 is you put 1 into this function, you will get answer 1 out as well. So 1 squared is 1. So you have g1. You will have g1. Then what g1 equals to? Okay, what g1 equals to? g1 equals to 2. Okay, g1 equals to 2. Let's put this into a flow chart. Okay, into a flow chart. This is where I can see them clearly. So I want to put a value into the function. First of all, I will put into the function fx. fx equals to x squared. Then I will get something out. Okay, it's like a manufacturing process. I put something in, I get some other thing out. And then I use the new thing to put into the function gx. gx is x plus 1. And then I get a new value out. I get a new value out. So for the process 1 I put in, I have 1 in. 1 got 1 squared, I have 1. And then 1 further put into that box, I will get 2. I will get 2. Okay, that's very nice and easy. Let's try a new number. Don't forget, what I can put into this box can only be r plus. Okay, which is 0 to infinity. Only r plus. Because what I can put in f, I restricted already from 0 to infinity. What I can put into g is negative infinity to 4. That's from the gx restriction as well. Okay, I have restricted. When I put 1, everything works fine. Okay, it can go from the top to the bottom. Let's try a new number. Let's try the number 3. I want to put a 3 into the first box. Okay, go into fx. What I will have here is a 9. Okay, it's a 9. Can we keep going? My question is, can we keep going? No, I can't keep going. Even though the number 3 can fit into the first function, it can't keep going for the second one. because it's out of the domain. It's 9, it's greater than 4. So I can't keep going, which means 3 is a wrong number to put into the function hx. Okay, 3 is a wrong number to put into the function hx. Which means, okay, 3 satisfies the domain for fx, but it's not satisfied for the domain of gx because the larger number. Which means the domain of fx is not the domain for the whole composite function. That's the first misconception from students. Students always think, okay, the inner function's domain is always the domain for the whole composite function, which is wrong. Okay, which is wrong. Why is wrong? I have to show you. Because 3 satisfies that, but we can't keep going and finish this chart. Okay, so that's the idea. Okay, that's the idea. So the domain is a question mark. What I can put in now is a question mark. I don't know what I can put in. Okay, I don't know what I can put in. I need to do further calculation to prove that. Okay, so I don't want to keep going with this question. If you get the basic idea, we can go back to this question. Okay, let's do a little bit complex example here. Okay, so, right. Let's say we want to calculate what is hx. Hx is g of fx. I can simply combine those two functions. Okay, I put fx into gx. Okay, I put fx into gx. So instead of x, you need to have x squared. So hx, if you talk about the rule, will be x squared plus 1 for sure. Okay, will be x squared plus 1 for sure. But the domain will be a question mark. The rule is always put the inner function into the outside function, but the domain will be a question mark. The most important thing for composite is talking about the domain. Okay, it's to talk about the domain, not like the rule. The rule is very easy. Just put the inner into the outside function, and that's it. So this is the rule, but domain is a question mark, and range is a question mark as well. Okay, we are talking about domain and range now by using the example I give you in the notes. So let's go back to this function. Okay, let's read about this function. For the function f, r to r, okay, function notation, everyone is too familiar with function notation. The first r is the domain, and mapping to r is just a fixed like set notation. It's always right as mapping to r. Okay. Fx equals to x squared minus 1. Then g is 0 to infinity, mapping to r. Okay, there's restrictions for square root function. Okay, the first question just asks you, state why g of f is not defined. Okay, let's state why g of f is not defined. Let's use the flowchart again. So this is g fx. This is g f of x. So first of all, I can put something into which function? Into the function fx. Into the function fx. That is x squared minus 1. I will get something out. I want to further put that into the box gx, the outside function. That's square root x. And then I will finally get some other things out. Okay, that's my flowchart. So the domain here is r, but the domain here is 0 to infinity. When we try one value in the first box here, I sub into that, I get out here. What is that? That is actually the range of f. Okay, what is that? That is actually the range of f. Right? This is the range of f. Because I put something in, I calculate the value, I got something out. That's the range of f. I want to put the range of f into gx and then get a final answer out. So if I put r here, okay, if I put r here, what's the range for fx? Can you calculate that for me? What's the range for fx? So x squared minus 1, what's the range for fx? -1 to infinity. Okay, -1 to infinity. What's wrong? What's wrong? -1 to 0 cannot fit into Gx. Okay, we have a larger range compared to the domain of Gx. Okay, so part of the range of f cannot fit into the domain of G. Okay, that's the main reason why this composite function does not exist. Okay, that's the main reason why this whole composite does not work. Some of the value, yes, it can work. For example, I put 0 in. No, I'm not 0. I put 1 in. I got 0, and then 0 can keep going with that. A lot of values can work, but for some particular value, it doesn't work. It can't keep going. So the question, how I can answer this question, for A, what I need to answer is the range of f, let's use math language, is not a subset of the domain of G. Okay, that is the reason why it doesn't exist. You can see I put any value in, okay, any value I like. I will definitely get a range from -infinity to -1 to infinity. And I check, okay, for part of the value is not a subset of this. Okay, it's not a subset of this. I can't keep going. That's why this composite function does not exist. So every time when they say the composite function does not exist, must means the inner function's range is not a subset of the outer function's domain. Okay, so make it in general, not always f or g. So inner function range is not a subset of the outer function's domain. Okay, it's always the case why it doesn't exist. For only reason composite function cannot exist is because the domain, the range is larger than the outside function's domain. That's the only reason. Okay, that's the only reason why it doesn't exist. But we can restrict what I can put here to make it happen. Okay, for example, what value does not work? -1 to 0 doesn't work. Okay, -1 to 0 doesn't work. So how I can make it work? By restrict the R. I'm not going to put all the values in. I've restricted to some part of the value to make it happen. So what should be in here is 0 to infinity. Okay, is 0 to infinity. Well, how I can find the 0? Okay, how I can find it should be 0 to infinity? Because if you find the intersection between this box and this box, you will find 0 to infinity is the intersection. So here should be a set that it is the range of f and it is also the domain of G. So that should be the correct value put into this box. Okay, then we go backwards. I want to achieve a range from 0 to infinity of that function. What the domain must be. Okay, what the domain must be. So if I can sketch x squared minus 1. If I can sketch x squared minus 1. That's why I said quadratic is very important. You use it in all different ways, like say composite function. So I know this turning point will be 0, -1, and I know this will be 1, 0, and this will be -1, 0. Okay, another thing I just remember. When I mean label the points, okay, what's the key point you need to label? Label means label as coordinates, not label as like a value. Let's say -1. That's not labeled as a coordinates. Okay, so coordinate must be a bracket, a value, comma, another value. So you must label in that way. It's not good enough to just say, oh, -1 on the axis. So you won't get that mark. So must be labeled as a coordinates. So that's the shape of the graph. What I want to achieve? I want to achieve a range 0 to infinity. Okay, 0 to infinity. This part and this part got a range of 0 to infinity. Okay, y value 0 to infinity. So those two parts of the graph get a value range 0 to infinity. So what's the corresponding x? What x you put in, you will get those values. That will be r except negative 1 to 1. You don't need to exclude negative 1 to 1 because that's just the 0 point. But you need to exclude any value in between negative 1 to 1. Okay, because in between negative 1 to 1, you will get negative values. You don't want negative values. So what we can do is we want this part of the x value and this part of the x value. So that will give you a range from 0 to infinity. Okay, from 0 to infinity. That's why we need to restrict it. We restrict it because we want to restrict the range from here to here. I don't want those range. Okay, how I can get rid of the range is I can get rid of the x value from negative 1 to 1. Then I can get rid of the range. And then I will have a range from 0 to infinity, and I can put into the function gx. Is that clear? Make sense? That's like you need to go backwards. Okay, you need to go backwards to see what x I can put in order to make the range fit the domain of G. Okay, to fit the domain of G. And then now this can keep going. 0 to infinity put into square root x, I will have 0 to infinity. Okay, so square root x look like this. Okay, square root x look like that. That endpoint is 0, 0. So from 0 to infinity, I can have 0 to infinity and I can have range 0 to infinity as well. So this is called the range of the composite. This is the range of the composite. The very beginning is the domain of the composite. Okay, range of composite and domain of composite. So this is like a flow chart. You see from the beginning, okay, you work forward first and then go to the middle. You say, oh, no, this can't fit. I need to cut some of my domain. Then you go backwards to see what I need to cut. Okay, what I need to cut. So after I cut that, that becomes my domain of the composite. And I keep following this flow chart. In the end, that will give me the range of the composite. Okay, that will give me the range of the composite. That's how composite function works. Maybe it's a little bit easy to just listen to what I'm talking about, but when you really meet different functions, different questions, it's very complex. Okay, it's actually very complex. But always remember, the range of f needs, like the range of the inner function needs to be a subset of the domain of the outer function. That's always the rule. If that rule fails, this composite function does not exist. How we can make it exist? We can restrict the domain for the inner function to make the range of the inner to be a subset of the domain of the outer. Okay, so that is the rule for composite function. So if you look at part B, define a restrict f star of f to make that exist, to make g of f star is defined, and find f of f star. So f star needs to be r except negative 1 to 1 mapping to r fx equals to x f star x equals to x squared minus 1. Okay, that's part B. So how we can restrict it? We restrict that. We make the domain smaller. We make the domain smaller. Before the domains are, now I will get rid of the part from negative 1 to 1 to make this composite function exist. And also ask you to find g of f star. Okay, g of f star. G of f star. Okay, we'll just write it that way. So g of f star is you put f star into the function g. You put f star into the function g. So g bracket f star x equals to, okay, gx is square root x. You put f star into that is this. Okay, it's g of f star x equals to square root x squared minus 1. fx is x squared minus 1. You put that into the function gx. You put it here. So instead of this x, you will have x squared minus 1. That is the rule for the composite. As I said, the rule is always put the inner function into the outside function. That doesn't affect by the domain or range. Okay, rule is that but f star must be restricted from R except -1 to 1. Any questions? We'll do another example later. Just let you finish your writing for this one first. Let me check. I want to do the exercise on page 21, question 8. Okay, if you finish that one, just have a look at the next question, page 21, question 8. I'll give you 5 minutes to think about question 8 first, and then we'll do that together. Class finish 9:20. Okay, we have enough time. So give you 5 minutes to think about it, and then we come back to that together. Okay, when a question give you a function notation, directly tell you what's the domain, that obviously is the domain. If a question just say gx equals to x plus 2, doesn't give you the domain, which means it's the implied domain. Okay, which is the implied domain. If it doesn't say anything, it's the implied domain. So implied domain for linear will be, what's the implied domain for linear? R. Okay, everything. So linear, no restrictions, everything can be the implied domain. So for this function, is gx is the inner function, fx is the outer function. So you don't really need to go to this box. It's just make me think clearly. So I put R into the function, into the gx. Gx is x plus 2. Okay, what I will get? Like, what's the range for linear? What's the range for linear? R. Okay, so linear look like this. So the range for linear will be R if there's no restrictions. So it needs to be R. This needs to be further put into the function f. So fx equals to square root x minus 1. But the domain of domain of f needs to be 1 to infinity because it's restricted here. Okay, it needs to be 1 to infinity because it's restricted there. So therefore, I can't have this r here. Okay, I can't have this r here. What I can have is only the intersection between this one and that one, which is 1 to infinity. So which means the range of g needs to be 1 to infinity. Okay, the range to g needs to be 1 to infinity. If I can sketch the function g is x plus 2. So 1, 2, 1, 2. Okay, a linear look like this. X, y, 0, 2, negative 2, 0. And what I want is 1 to infinity. Okay, 1 to infinity. 1 is here. Okay, 1 is here. Negative 1 will give you 1. Okay, negative 1 will give you 1. So you want level 1 and above. You want level 1 and above. So you will start from this point. Is this blue part of the graph will work. Okay, is the blue part of the graph will work. So why? I want range 1 to infinity. Range is the level. Okay, I want level 1 and above. So I sketch a line at level 1. So if I can extend this line, I want something from level 1 to infinity, which is this part of the graph. Okay, this part of the graph. So what x can give me this part of the graph is from negative 1 to infinity. You can see if you draw a vertical line down, it's all mapping to this part. So it's -1 to infinity can give me that range. So I can't have that. What I can have is -1 to infinity. What I can have is -1 to infinity. Therefore, it asks me what is the domain of G such that this function will exist. If it doesn't say anything, we assume that's the implied domain, which is R. But because I want to make this function exist, therefore, you will answer the domain of G is -1 to infinity. Okay, the domain of G is -1 to infinity. What's the range of the composite? Domain of G is that it is also the composite. The first one is the composite function's domain. What is the range for the composite for this question? What is the range for this composite? If you can think about that. There will be some other question ask you the range of the composite. So the range of composite will be the last box. Okay, we keep going. It is the last box here. So what is the last box here? So now this become your new domain. Okay, domain of f. This is a square root function. What's the range of the square root function? You put 1 in, you get 0. You put larger values in, you get larger numbers. So what is the range? 0 to infinity. So if I keep going for one more step, that's 0 inclusive to infinity. Okay, that's the range of f of G, which is 0 to infinity. That is the domain of G. That is also the domain of composite. That is also the domain of the composite. It's not only the domain of G, it is also the domain of the composite, which can make this composite exist. And if you can think further of the function, what's the rule look like? F of gx, you put gx into the fx. That will be square root. Instead of x, you will put gx in, which is x plus 2. The -1 still stay there. Okay, the -1 still stay there. And that gives you square root x plus 1. Okay, square root x plus 1. That is the rule, that is the domain, that is the range for the whole composite. Okay, so that's the basic idea of the composite. Well, it's not really basic, it's like basically everything for composite, but there will be more complex equations, more complex range for you to think about. So that's the hard thing of composite function. Okay, so for homework, I want you to finish everything before page 21. Okay, everything before page 21. It's about 10 questions, okay, 10 exercise questions. So I want you to do all of this composite function. They will be harder than the book exercise. Okay, this is I find from maybe mock papers or some other books. So it will be 10 questions. So try them. Some of them you may think is too hard to do it. It's okay, but do the ones you think you can definitely do. I think for the first 2 pages you can definitely do them. Okay. I will check that on Monday or Tuesday class, and if you finish that, you can go back to the book exercise. Okay, you can go for the book exercise. Any questions for today? Composite? No?